Hello friends. Today we will see or we'll cover P channel enhancement MOSFET characteristic module number 14. Now before start with the characteristics, just quickly revise the working of P channel enhancement MOSFET. Okay. So what is our basic thing? We have to create the channel in between this P type of the semiconductor. Now to create the channel, what we have to do? We have to supply the connection between these terminals. So to create this channel, यहाँ पे हमें P channel create करना है, तो हमें गेट एंड सोर्स के बीच में हमने कौन सा सप्लाई कनेक्ट किया था? We collected the negative to the gate and positive to the source. So what happened here? As in this N channel, some minority charge carrier, that is holes, is present. So because of this negative supply, ये negative है, it will attract the hole towards this oxide layer. तो यहाँ पे क्या start होंगे? Holes start होंगे create होने के लिए. Now once your VGS is reaches to threshold voltage, then what happen? Your channel is now get created. So यहाँ पे channel form हो गया. ठीक है? And again when we give the connection between drain and source, drain to the negative and source to the positive, what happen? Your drain current start flowing. Okay. So this is the working of P channel enhancement MOSFET. Now what are the characteristics? So this E MOSFET basically divided into two characteristics: output characteristics, or other name is the drain characteristics, and another one is the transfer characteristic. Now what is the drain characteristic of E MOSFET? It is the graph between the drain current and drain to source voltage, keeping the VGS constant at a particular value. Okay. So what is the drain characteristic? It is the graph of drain current versus drain to source voltage for different values of VGS. Now same thing again, if we compare this characteristic with the N channel, तो यहाँ पे सिर्फ difference क्या है? VGS आपका P में negative देते हैं, while in N channel we will provide the positive voltage. Okay. So same thing, this drain characteristic divided into the three region. One region is the linear resistance region or ohmic region. Then this region is the saturation region, and below this is the cutoff region. Okay. So basically divided into three region: ohmic region or linear region, constant or saturation region, and cutoff region. Okay. So now see, first we will cover this linear region. So for small value of the VDS, your drain current increases linearly with increase in VDS. So this region is called as the ohmic region. तो इसमें क्या हो रहा है? अगर आपने थोड़ा भी VDS दिया तो आपका drain current linearly increases होता है. ठीक है? Next, after certain value of the VDS, the pinch off takes place. हमने देखा है pinch off occur होता है and your drain current is remain constant, or we can say the saturate. Okay, so this region is called as the saturation region. And if gate to source voltage is less than the cutoff voltage or threshold voltage, okay, then your device is not on, ID becomes 0. So this region is called as the cutoff region. यही हमने सब N channel में भी देखा है. So same thing, सिर्फ आपके voltage polarities change होती हैं. ठीक है? Now next. So वही मैंने एक्सप्लेन किया है, वही यहाँ पे लिखा है. So ohmic region, constant current region, and the last one is the when your get to source voltage is below the threshold voltage, your drain current is reduced to 0. That is nothing but your cutoff region. Now next characteristic is the transfer characteristic of E MOSFET. So this transfer characteristic is basically the drain current versus VGS, that is the gate to source voltage. Now looking at this figure, see here, for VGS is less than threshold voltage. ठीक है? If my VGS, that is gate to source voltage, is less than the threshold voltage, what will happen? वहां पे क्या होगा? चैनल ही फॉर्म नहीं हुआ होगा and your drain current becomes zero. So for VGS less than the VTH, my drain current is zero. This is because what? No significant channel is induced between the source and drain region to support to flow the charge carrier. Then next, for VGS greater than VTH, your drain current increases sharply with increase in the VGS. देखो यहाँ पे that means your MOSFET is now turn on. ये ट्रांसफर कैरेक्टरिस्टिक्स में क्या एक्सप्लेन किया है? जब तक मेरा VGS लेस देन VTA तो मेरा ड्रेन करंट क्या है? जीरो है. Once my VGS it will be reaches to this threshold voltage, then your drain current increases linearly and your MOSFET it get turn on. So again, if we compare these transfer characteristics, exactly the same case, but what the polarities it should be get opposite. Okay. So same thing for VGS less than VT, the drain current is zero. And for VGS greater than VTH, the drain current increases sharply with increase in VGS. Now, what are the different application of enhancement MOSFET? We can use as for switching application. We can use as an amplifier. This E-MOSFET can be used in inverter circuit, different types of the motor drivers. We are using digital controllers. We can use E-MOSFET in power electronic integrated circuits and digital electronic system as well. So in next module, basically important two application we will cover, that E-MOSFET can be used as a switching application and E-MOSFET are used as an amplifier. Thank you.